Okay, parallel lines. This is 5.7, 5.6. Parallel lines. So something we need to know about parallel lines. They will never intersect. If they never intersect, that means they are rising or decreasing at the same rate. Okay? And when we say same rate, that means it's like a same slope. Slope represents rate. Okay? So I want to give you a visual here. If we were to graph these two lines, y is equal to x minus 1 and y is equal to x plus 2. I want you to make the coordinate plane in your notes and graph them. And then we're going to compare to see what's going on with them. All right, looking at both of these, I have y is equal to x minus 1. That has a y-intercept of -1, so I'm going to make my dot at -1. And I have a slope of 1. That means I go up 1 over 1, up 1 over 1, up 1 over 1, or down 1 over 1, down 1 over 1. Okay. The next one, I have y is equal to x plus 2. I have a y-intercept at 2, same slope. Up 1 over 1, up 1 over 1, up 1, or down 1. And when we look at them, yes, we should notice they are parallel. Parallel lines, are they ever going to intersect?
Nope.
They're not. They're always going to increase at the same rate, which means slope. So when I say same rate, I need you to be able to understand that means slope. They are increasing or decreasing at the same slope. That means that they're not all of a sudden going to slow down. Lines just keep going on for infinity. Okay? So, we're going to write some properties down of parallel lines. Parallel lines. What we need to know with parallel lines, they have the same slope, but different y-intercepts. So if they didn't have different y-intercepts, that would mean that they are the same line. So to identify that they're parallel, they need to have the same slope with different y-intercepts. So if I want to identify which lines are parallel, how I identify it, I compare slopes. So you're always looking, when you're identifying, you're comparing the slopes of both lines. If they are parallel, that means they are increasing or decreasing at the same rate. For example, y equals 3x minus 4 and y equals 3x plus 2. They are parallel because they both have the slope of 3. They're both going to go up 3 over 1, up 3 over 1. So they just have the different y-intercepts. I want you to identify which ones are parallel here. And I need you to think pair share with your table partner on that. Okay, we have a list of lines here. What are one set of lines that are parallel? The second and third one. And I know they're parallel because why? They have the same slope. So that means, and I just want to give a visual, I have something like this. I'm not even going to scale it. But I have a y-intercept of plus 1, and then I'd go up 2 over 3, up 2 over 3, down 2 over 3. Or I have a y-intercept of minus 1, and then I'm rising at that same rate. Up 2 over 3, up 2 over 3, or down 2 over 3. Anyways, that's my human error there because I messed up. But they are parallel. All parallel lines will look like this, or decreasing in nature. Okay, Okay, Scott, what's another set?
First and fifth one.
The first one and the fifth one. So 3x minus 2 and 3x plus 2. Perfect. Why do we know that?
3x.
Because of the 3, because they have the same slope. Do I have anything else with the same slope? No, I do not. So that is good. Notice that I threw this negative 3 in here to try to mess you up. So that was me being tricky. Okay, to identify parallel lines, you need to get them into slope-intercept first. That is the hardest part here. So I'm going to be giving you them in sometimes I'll be giving them to you in slope-intercept form, but a lot of times I'm going to give them to you in standard form. And I'm going to say, hey, are these two lines parallel? And you're going to be expected to get it into slope-intercept form. Okay, looking at these two equations, I have 3x plus 2y is equal to 4, and y is equal to negative 2/3 x plus 3. I want to know, are they parallel? Well, it looks to me like this second one, I already have this second one in slope-intercept form. So I know that my slope, what's my slope of my second one? Negative 2/3, just negative 2/3. So I want to see, hey, does this first equation have a slope of negative 2/3? Okay, so I'm going to just find out. So I have 3x plus 2y equals 4. Move my 3x by subtracting it. I get 2y is a negative 3x plus 4. That's me subtracting that 3x. Now divide everything by 2. Y is equal to a negative 3/2 x plus 2. Are they parallel or not? They are not parallel because this slope is negative 3/2 and it does not equal the slope of negative 2/3. So they are not parallel. Okay, I'm going to get these two equations. I want to check to see if they're parallel. I'm going to get them both into slope-intercept form. This first one, I got 6y is equal to a negative 12x plus 12. I got the negative 12x by subtracting 12x to both sides. Now I'm going to divide everything by that 6. And I get y is equal to a negative 2x plus 2. This one is already in slope-intercept form. So now I just need to compare. Negative 2 is the first one's slope, and negative 2, so they are parallel. I think that's about where I want to get with you today. Tomorrow we're going to be writing equations of lines given that it's parallel to one and it goes through a point. Seriously, that's going to be on. That's going to be on the video.
No,
Nope.